Okay, so we are done with kinematics for now. We are moving on to what's called dynamics. The difference between kinematics and dynamics is basically kinematics studies the how of motion without regard to what causes the motion. Okay, and so kinematics is the how, dynamics is more about the why. Okay, and so dynamics deals with forces and Newton's laws of motion. Now, we're still under topic 2, which is mechanics, because mechanics is by far the biggest topic in all of IB physics, and we are going to be doing mechanics probably until February or March. So we're still studying moving objects, but we're just studying them in a different capacity. Okay, dynamics and Newton's laws are probably one of the most important part of mechanics, and we're going to continue to draw on everything we've learned so far this year. Now, due to its size, I typically split dynamics into 2 separate units, kind of like I do with kinematics and projectile motion, and most likely we will be doing dynamics through Christmas. Okay, and so usually by this point in the semester we have 2 units left. Newton's laws take a long time to get through, and then after that we will do a second unit just for Newton's second law, which is probably the most important law in all of mechanics. Okay, and then hopefully, if everything goes okay with timing, we will be time for Christmas by the time we finish dynamics. Okay, and then when we come back from Christmas, we'll still be doing mechanics, so that's fun. Alright, so today we're just going to kind of ease into mechanics. I kind of briefly talked about the difference between dynamics and kinematics before. Remember, kinematics, we study the how and not the why of motion. So we've been talking about things like displacement, velocity, and acceleration. Now we're going to talk more about forces. Okay, so we're going to talk about forces. Newton's laws of motion is going to be the main focus of this unit, and really the next unit as well. And so basically, if you were to take dynamics, which is the why of motion, and kinematics, which is the how of motion, if you put those two together, theoretically, you could completely describe how and why an object moves, and that allows you to do lots of really interesting and useful things, whether it's build high-powered artillery for weapons, or you could send a rocket to space or to the moon, or stuff like that. As long as you can understand how and why things move and make predictions about how and why they're going to move based off of forces, then you can do lots of really useful things with mechanics. Okay, and I only named a few, but there's obviously lots of other dynamical objects you could talk about. You could talk about like satellites that carry like GPS and cell phone signals being put into orbit and then moving around the Earth, or you could talk about like high-speed race cars, or designing engines that are power high-speed race cars. Okay, once you understand the how and whys of motion, then you can do lots of really cool engineering and sciencey stuff with that. In fact, if you study mechanical engineering in college, you'll learn. You'll take a separate class just for dynamics by itself. But anyways, before we get into Newton's laws of motion, because we're not quite there yet, let's talk about some more basic stuff. Okay, so let's talk about mass first of all. Alright, so what is mass? So here are just some random definitions for you to stick in your notes. So objects that have matter have a property called inertia. And basically what inertia is inertia is an object's tendency to keep moving the same way that it's already moving. If it's at rest, it wants to stay at rest and it resists changes in motion. And if it's moving, if you try to stop it from moving, then, the object wants to keep moving the way that it was before. And some objects do this better than others. Now, the way we quantify inertia is through what's called mass. Okay, so the more mass an object has, the more inertia it has. Okay, that's basically how that works. Okay, so mass is the quantitative measurement of an object's inertia. Okay, now the symbol for mass is typically a lowercase m. Sometimes, depending on the context, you'll see that as an uppercase m, but usually I like to write mass as a lowercase m. The SI unit for the mass, as you know, is the kilogram. If you want to know why is the gram not the SI unit for mass, I don't know. There's other systems of units out there besides the SI system, and in some other units, the unit for mass, or sorry, in some other systems of units, the unit for mass is the gram and not the kilogram. It just so happens in the SI system, the kilogram is the base unit for mass. Okay, if you want to know what is a kilogram, just as a frame of reference, 1 kilogram is about 2.2 pounds. Okay, so that tells you what mass is, but let's kind of try to distinguish between mass and weight, which sound like they're the same thing, but they're actually two completely different quantities. Okay, so on this slide here, you can again add this down to your notes. This is just like a comparison between mass and weight. Okay, so here are some of the key differences between mass and weight. Okay, mass is a scalar, weight is a vector. Okay, that means weight has both magnitude and direction. Okay, the direction of weight tends to be down because weight is actually what we call the force of gravity. We'll talk about that later. Mass is measured by a balance. If you think like a triple beam balance, weight is measured by a scale. And if you thought those were the same things, they're not. Mass is a measurement of an object's inertia, but basically what determines mass is the number of atoms which make up an object. Okay, so in other words, if let's say I have like a block of cheese, the block of cheese has some number of atoms. If I take my block of cheese to, let's say, space, my block of cheese still has the same number of atoms, unless I ate some along the way. Okay, that means whether I'm on Earth, or I'm in space, or I'm on the moon, or, whatever, my block of cheese still has the same mass. Okay, because I haven't changed the amount of inertia making up the block of cheese. I haven't changed the number of atoms or the amount of matter making up that object. Weight, on the other hand, has to do with the pull of gravity. And we'll talk more about that later. The unit for mass is the kilogram. The unit for weight, which is a force, is the newton. We'll see this later on, but newtons are the unit for force. Mass is a measurement of an object's inertia, and weight is a measurement of gravity's pull on an object. So going back to the block of cheese example, my block of cheese has the same mass on Earth as it does on the moon, but it would weigh a different amount on the moon because gravity has a different effect on the moon than it does on Earth. Okay, and so on this slide we can kind of see some examples of the concept we just talked about. Here in the top right, you can see if you take the same 2 kilogram block, if you take it from the Earth to the moon to deep space, the mass is the same. Okay, no matter where you are, but the weight changes from place to place. Okay, if you don't know what the difference between a balance and a scale is, here you go. Okay, balance tends to rely just on gravity pulling down an object onto a surface, whereas a balance, you typically have two different surfaces, and you might think it has to do with gravity, but it doesn't so much have to do with the direct force of gravity as it does the ratio of two objects being balanced. Okay, so balance determines mass, scale determines weight. Okay, so the last thing we're going to do in this video, I want to make this a short video, but the last thing we're going to do in this video is watch a fun little video clip about mass versus weight, and then in the next video we'll talk more about forces and Newton's laws of motion. Okay, so I will link this video here. I hope you enjoy. As always, please let me know if you have any questions, and I'll see you guys in the next video.